Hello everyone. Today I would like to share with you the property of Laplace transform. The first property is the linearity of Laplace transform. Okay, Laplace transform of the alpha ft plus beta gt. So this alpha and beta is the constant, so we can take it out. So alpha Laplace transform of ft and beta Laplace transform of gt. So Laplace transform of ft is, we call it as a fs. Okay, so alpha fs plus beta gs. Now, let's go through an example. By applying the linearity property of Laplace transform, evaluate the Laplace transform of 3 plus 4t squared. We can refer to the table of Laplace transform. Okay, just now the question is 3 plus 4t squared. So 3 actually is a constant a. So a over s. So for the Laplace transform of a, you will get a over s. And another one is t power of n. Okay, t power of n, you will use this formula. N factorial divided by sm plus 1. So therefore, this question we can solve it like Laplace transform of 3 plus Laplace transform of 4t squared. So 4 is a constant, then t squared. So this will equivalent to 3 over s, okay, as I mentioned to you just now, from the table of Laplace transform. Okay, and then plus with 4, okay, t squared t. If your n is 2, so you will get 2 factorial divided by s power of 2 plus 1, so s power of 3. So I write down here 2 factorial divided by s power of 3. So 3 over s plus, okay, 4 times 2 factorial. So 2 factorial means 2 times 1. So 2 times 4, you will get 8 divided by s power of 3. Okay, let's look at another question. The second question, Laplace transform of t minus 2 power of 3. So for this question, we need to extend it, t minus 2 power of 2. So this means is t minus 2 multiplied with t minus 2. So what is the answer for this? So you will get t squared minus 4t plus 4. Okay, you multiply in t squared. Okay, minus 2 minus 2 minus 4. Okay, so plus 4. So you will get t squared minus 4t plus 4. And then you must, so what about this one? If t minus 2 power of 3, this means you have t minus 2 multiplied with t squared minus 4t plus 4. So when you multiply in, you will get t power of 3 minus 4t squared plus 4t. And then this one, minus 2t squared plus 8t minus 8. So when I simplify, I will get t power of 3 minus 6t squared plus 12t minus 8. Okay, so this is t minus 2 in the bracket power of 3. So if I want to Laplace transform of this one, so I would write it right. T minus 2 power of 3, so equivalent to Laplace transform of t power of 3 minus 6t squared plus 12t minus 8. So this will equivalent to Laplace transform of t power of 3 minus 6. Okay, 6 is a constant, so you can take it out. And then Laplace transform of t squared plus 12, also a constant. Then Laplace transform of t minus Laplace transform of 8. So from the table, as you know, t power of n equal to n factorial divided by s power of n plus 1. This is the Laplace transform table. So in this case, I will get 3 factorial divided by s power 4 minus 6. So this one is t power of t squared, I will get 2 factorial divided by s power of 3 plus 12. Then I have 1 factorial divided by s squared minus 8 over s. Okay, so I will get 3 factorial. This means 3. So this means is 3 times 2 times 1. Okay, 3 factorial means 3 times 2 times 1. So I will have the 6 divided by s power of 4 minus 2 factorial times 6 is 12 divided by s power of 3 plus 12 divided by s squared minus 8 over s. Okay. Next question is Laplace transform of cos squared t. Okay, for the cos squared t, we cannot directly perform the Laplace transform. Therefore, cos squared t actually you can use the identity. Okay, use the identity. So cos 2t actually is equal to 2 cos squared t minus 1. So we will use this for here. Okay. So cos squared t is equivalent to cos 2t plus 1 divided by 2. So now we can do, or we can perform the Laplace transform. So now Laplace transform of the cos squared t equal to half of the Laplace transform of cos 2t plus Laplace transform of 1. So this is equivalent to, when you check for the cos 2t for the table of Laplace transform, so you will get the cos at is equal to s over s squared plus a squared. Therefore, from here, we can know that the a is 2. The a is 2. So s, okay, based on this fs, so s over s squared plus a squared. A is 2, so a 2 power of 2 plus Laplace transform of 1. So 1 is 1 over s. Is referred to a is 1 over s. Okay? It's quite simple. And then the next question, Laplace transform of sinh squared 2t. So this one, we also need to use the identity. So from the identity, cos 4t is equal to 1 plus 2 sinh squared 2t. So this sinh squared 2t is equal to cos 4t minus 1 divided by 2. Okay, this is the identity. So therefore, Laplace transform of sinh squared 2t is referred to Laplace transform of the cos 4t minus 1 divided by 2. So the 1 over 2 here is a constant, so you can take it out. Laplace transform of the cos 4t minus Laplace transform of 1. Okay, so this will equivalent to, we refer to the table. For a cos at, you will get s over s squared minus a squared. So you will get s over s squared minus a. A is 4, so 4 squared minus 1 over s. Next question is Laplace transform of 3 cos 3t cos 2t. Again, from the identity, we have cos A cos B equal to half of the cos A plus B, and then plus with cos A minus B. So this is the identity. And if we compare here, cos A, cos B, cos 3t, cos 2t. So we will get all this. Right? So this will equivalent to half of the cos 3t plus 2t plus with cos 3t minus 2t. So this will equivalent to half of the cos 5t plus cos t. So next, don't forget I will have the 3 cos, right? So just now the question is 3 cos, 3t and cos 2t. So supposedly I will have the 3 here. Okay, so I change it. So I will have a 3 over 2. Okay, 3 over 2. Then you multiply with the cos 5, Laplace transform of cos 5t and Laplace transform of cos t. So this will equivalent to 3 over 2 cos 5t. So you will get s over s squared plus 5 squared. Then plus with cos t, you will get s over s squared plus 1 squared. So you can simplify s over s squared plus 25 plus s over s squared plus 1. Okay, that's it for this question. And we move to another question. Question F, Laplace transform of sine 2t plus 1 over 3 pi. Again, from the identity sine 1a plus b, okay, sine a plus b, we can get sine 2t. We can get sine a cos b plus cos a sine b. So now we have the sine 2t plus 2 over 3 pi. So this is the sine for the question. And then we can get the sine 2t cos 2 pi over 3 and then plus with cos 2t sine 2 pi over 3. So this will equivalent to the sine 2t. Okay, and cos 2 pi over 3 can get negative 1 over 2 and then plus with cos 2t and then sine 2 pi over 3 you may get square root of 3 over 2. Okay, now let's do the Laplace transform. So Laplace transform of the sine 2t plus 2 pi over 3, you can get half of the Laplace transform sine 2t. Okay, we just use the answer here and then the square root of 3 over 2, this is the constant, then Laplace transform of the cos 2t. So this will equivalent to negative half. For the sine, you will get 2 over s squared plus 2 squared from the Laplace transform table. For the cos 2t, you can get s over s squared plus 2 squared. So you can get 1 over 2 square root of 3s minus 2 and then s squared plus 4. Okay? And then last question, we have the Laplace transform of 2 exponent negative t minus 1, negative t minus 1 plus exponent t. Okay, so we can rewrite it into Laplace transform of the 2 exponents. So we multiply in this one. So we have exponent negative t plus 1, right? So exponent 2 exponent negative t and then exponent 1 plus with exponent t. So this will equal to 2 exponent, because there is no t, so exponent we assume as a constant. So Laplace transform of exponent negative t plus Laplace transform of exponent t. So from the table, we go back to the table. Exponent at is equal to 1 over s minus a. Therefore, we can say that 2 exponent divided by s minus a. So a is, what's the value of a? A is negative 1. So negative 1. So s plus 1. Plus with exponent t, so you will get 1 over s minus 1. So that's it for the linearity properties. Hope you can understand. Next, we move to another example. Given that a cos at equal to half of the exponent at plus exponent negative at. By applying the linearity property of the Laplace transform, show that the Laplace transform of cos at equal to s over s squared minus a squared. So to solve this question, we Laplace transform the cos at. Okay, so this will equivalent to half of the Laplace transform of the exponent at plus with Laplace transform of the exponent negative at. So this will equivalent to half of the exponent at. Exponent at is, you can get 1 over s minus a. Okay, plus with 1 over exponent minus at. So for the Laplace transform of this one, you will get 1 over s plus a. So this, okay. So I simplify it, I can get s minus a and s plus a. And this one I multiply up, so I have s plus a plus s minus a. So I will get, so s and s, I have 2s, okay. This one cancel out, so I can get s squared minus a squared. So 2 cancel out, and then I can get s squared minus a squared. So now I can prove that the Laplace transform of the cos at is equal to s over s squared minus a squared. So proof. And then we go to the second example. Given that the Euler formula exponent I theta equal to cos theta plus I sin theta, show that the Laplace transform of the cos at equal to s over s squared plus a squared, and Laplace transform of the sin at equal to a over s squared plus a squared. We can use this formula. Laplace transform of the exponent jat, because you are talking about the question requires you to use this Euler formula to prove that this Laplace transform of the cos is equal to this, and Laplace transform of the sin is equal to this. So we can use this Euler formula. So Laplace transform of the exponent j theta equal to cos theta j sin theta. Now the cos is at, is not sin. It's not the theta, it's the at. So we use the Laplace transform of exponent jat equal to the Laplace transform of the cos at plus j Laplace transform of the sin at. Okay? And then from the table, we know that the exponent at is equal to 1 over s minus a. So therefore we can say that the Laplace transform of the exponent jat is equal to 1 over s minus ja. Okay, 1 over s minus ja. So if we look at the question, how we can get the s over s squared plus a squared and a over s squared plus a squared? it seems that we need to multiply with s plus ja, okay, because we need the s plus ja as a denominator. So this one we time with s plus ja and s plus ja. If we cancel out, you still get the same value, this one. So we just want the denominator. We have the value of s plus ja. Okay, if s plus ja, s minus ja, at the end we can get the something, right? S squared, either plus or minus of a square, right? So, okay, we simplify it. Okay, let's say we have this one. We can simplify. So let's simplify together. So s plus ja, and then the denominator we have s squared, okay, minus with j squared a squared. So don't forget the j squared is equal to -1. So therefore, we have s plus ja divided by s squared minus, so it's a plus a squared. So we get s over s squared plus a squared plus with j, okay, we take out the j, and a over s squared plus a squared. So from just now, we get the first one. So this is the first one. And then at the end, we get this one, this number second. So try to compare. Compare 1 and 2. Okay, so you will get Laplace transform of the cos AT. You can get, okay, you compare this one. Cos AT, and then is equal to s over s squared plus a squared. Whereas if you compare for the Laplace transform of the sin AT, okay, compare for the sin AT, you will get j, right? J sin AT, and then this one is j a over s squared plus a squared. So this means that I can get a over s squared plus a squared. Okay, do you understand? So I hope you can understand for the property of linearity properties. Hope you can understand and enjoy the watching. Okay, thank you very much, class. See you again.